faithfully sharing value and exploring great books worldwide. Hi, this is Sally's Book Talk. Today we're diving into a book called Exam Brain Science. Brain Science, with the subtitle Efficient Memory Methods in Brain Science. Almost everyone has experienced exams, from big entrance tests to qualification and certification exams after entering society. Each one tests our learning outcomes, especially our memory skills. But memory has a lot of uncertainty. Like you've clearly memorized something, but in the exam hall, you just can't recall it. When learning, some people remember easily while others just can't, and so on. Actually, memory seems elusive, but there are rules to follow. If you don't understand memory rules and just drill blindly, you'll get half the results with double the effort. The author of this book, Yuji Ikedaya, is a professor at the University of Tokyo's Faculty of Pharmaceutical Sciences and director of Japan's Center for Information and Neural Networks. So he's also a famous best-selling author with books like The Evolved Brain, The Simple Brain, and The Complex Brain, selling over 1.5 million copies total. This exam brain science has been a bestseller in Japan for over a decade, helping countless Japanese students achieve great results. Based on brain science, the book details memory laws and outlines methods to boost memory and improve exam scores. And these methods are super helpful for daily work and study too. Next, I'll break down the book's main content into 3 parts for you. First, why do we always forget? Second, how to improve memory efficiency. Third, besides boosting memory, what other ways can optimize learning in exams? First up, part 1. Why do we always forget? Have you ever had this experience while studying? You've just learned something new, try to recall it, but can't. Even if you finally memorize it, after a while, it's completely gone. Why is memory so hard? To uncover why we forget, let's see how memory forms. Memory is the trace information leaves in the brain. Brain information transfer, including memory formation, happens through neural circuits. Neural circuits are the brain's neural networks. This network connects billions of nerve cells with connecting channels called nerve fibers. Nerve signals run back and forth on neural circuits, transmitting and processing information. And to draw an analogy, nerve cells are like your home and office. Nerve fibers are like city roads. When the roads connect your home and office, they form a circuit. You can move around on this circuit, handling tasks. When the brain receives various sensory signals from the outside world, it transmits their information through numerous neural circuits to a part crucial for forming memories: the hippocampus. These sensory signals include vision, hearing, smell, skin sensations, and so on. The hippocampus serves as a temporary storage site for memories, storing and processing short-term memories. Short-term memory refers to memories stored for a very short time, easily forgotten, with a small capacity that can't hold too much information at once. For example, if you're boiling water, waiting for it to boil, and you get a call from a friend, chatting happily might make you completely forget about the boiling water. This is because boiling water is a short-term memory. Once interrupted, it's quickly forgotten. Next, the hippocampus transfers short-term memories to the cerebral cortex via neural circuits, storing them long-term to form long-term memories. Long-term memory refers to memories stored for a long time, with a large capacity. When we recall past events, like writing answers on an exam, we're accessing long-term memories. If short-term memories aren't transferred to long-term memory by the hippocampus in time, they're quickly forgotten completely. So, how can we turn short-term memories into long-term ones? First, you need to know that not all short-term memories are stored as long-term ones, because there's too much information entering the brain beyond its capacity. Although we can't accurately measure the capacity of long-term memory storage in the human brain yet, researchers speculate that if we stored all the information we've ever seen, heard, or felt in the cerebral cortex, it would overload and malfunction within minutes, like a computer crashing. Therefore, to efficiently use limited storage space, the brain categorizes short-term memories into necessary and unnecessary information based on their value. Only information judged as necessary is transported to the cerebral cortex, stored long-term as lasting memories. The inspector determining information necessity is the hippocampus we just mentioned. Typically, the hippocampus's review process is extremely strict, taking at least a month. So what criteria does the hippocampus use to evaluate information? Think about it. Eating spoiled food causes food poisoning. This kind of information versus Socrates dying in 399 BC. Which type do you remember more easily? Without a doubt, naturally the first one. The difference is that the former directly relates to survival. So, the hippocampus's clearance standard is whether information is indispensable for survival. Most information we learn in school, like English vocabulary or math formulas, the hippocampus deems forgetting some non-life threatening, so it constantly deletes these short-term memories, preventing their conversion to long-term storage. Well, that's why you memorize then forget repeatedly. Hearing this might discourage many, but it's the reality. Compared to remembering, the brain is naturally better at forgetting. Forgetting entirely or losing memories over time are both inevitable. Why can't our brains be like computers, remembering perfectly after one save? Actually, we should be grateful for this brain design. Otherwise, normal life would be impossible. What if our memory were too good? There's a rare medical condition called hyperthymesia, where patients remember every daily detail. But this isn't necessarily beneficial. An overloaded mind hinders thinking, blurs reality with imagination, eventually trapping them in delusions and causing mental illness. All right, that concludes part one. Of the vast information our brains receive, only survival critical data gets transferred by the hippocampus to the cortex as long-term memory. The rest is forgotten. If this is the brain's nature, are we powerless? Of course not. Memory follows rules, and by aligning with them, you can discover techniques to boost memorization efficiency. This is the main content of part two we're about to discuss. How can we trick the hippocampus into categorizing survival irrelevant knowledge as necessary information? And the first method is reviewing, repeatedly feeding information to the brain to deceive the hippocampus. This makes the hippocampus think such persistence must mean vital information, thus opening access to the cerebral cortex. Confucius said, "Isn't it a pleasure to study and practice what you've learned?" This embodies the same principle. Actually, when we think we've forgotten knowledge, it hasn't disappeared completely. Weakened neural connections turn it into latent memories that are harder to retrieve. Repeated memorization quickly strengthens these weakened neural connections. These latent memories then help us recall knowledge more easily, boosting memorization efficiency. For example, you memorize an ancient text, but recall only 1 or 2 sentences after 2 weeks. Do you think the rest is completely forgotten? But when you revisit it, you'll find relearning much easier than the first time. Reviewing sounds simple, but there are tricks to doing it effectively. First is timing. The book cites Ebbinghaus's forgetting curve to explain. Ebbinghaus was a famous German psychologist who conducted in-depth memory research. He found that after memorizing meaningless content, almost everyone forgets information at roughly the same speed. Meaningless content here refers to phrases made of unrelated characters with no inherent meaning. He summarized this forgetting pattern into a curve. We learn from it that forgetting is rapid initially, then slows down. Within 4 hours of memorization, people forget nearly half the content. After this, forgetting slows and the curve stabilizes. So, for optimal review, timing should follow a tight first, loose later approach, matching the forgetting pattern. The book suggests 4 review sessions at specific intervals. First review after 2 days, then after 1 week, 2 weeks, and finally 1 month. Note, even if not following this exactly, the first review must happen within a month, or latent memory can't aid recall. Because latent memories only last about a month. This matches the hippocampus's 1-month review period. So, knowledge reviewed after too long an interval, For the hippocampus, it's no different from learning new material. Beyond timing, review content is also crucial. Review means repeating the same content. If the content changes, review won't work. Also, review like first-time learning, not just reading, but writing and reading aloud, engaging multiple senses. This sends more info to the hippocampus, increasing the chance of tricking it. The third key point in reviewing. Third, focus on output, not just input. As mentioned earlier, repeated review makes the hippocampus think, this info keeps coming back. It must be vital. From the hippocampus's perspective, if info is used this frequently, it gets classified as essential. So besides rereading textbooks, do practice problems or tests frequently, making your brain output more for better memorization. But boosting memory through review takes significant time. Thus, plan exams well ahead, allowing ample review time to avoid last-minute cramming. Plus, heavy cramming causes memory interference. Memory interference means cramming too much info, short-term overloads, limited capacity, causing new memories to disrupt old ones, leading to confusion or loss. It's like pouring water into a large bottle with a narrow neck. Though the bottle's capacity is large, dumping a bucket in at once wastes most water. So when memorizing, don't rush. Take it slow and steady.
During this, some might ask, is it possible to reduce review sessions, saving time and energy?
Without compromising effectiveness? Answer's yes. Next, we'll cover the second method to boost memory efficiency, enhancing LTP. LTP stands for long-term potentiation. It refers to the process where repeated stimulation from new knowledge strengthens neural connections, improving information transmission efficiency. Even after stopping new input, this enhanced connection state persists. In other words, neural connections remain strengthened after stimulation, preserving memories. Thus, LTP is the foundation of brain memory. Experiments show animals deprived of LTP via drugs or genetic modification cannot form any memories. Conversely, animals with enhanced LTP through external stimuli show improved memory. Therefore, making the hippocampus prone to LTP boosts memory efficiency. How can we achieve this? The author presents two methods. First, generating theta waves during memorization. Theta waves are brainwaves closely tied to memory, rarely appearing during daytime but common during sleep. When memorizing, if theta waves are present, even minimal stimulation, like 1/10 the usual, can trigger LTP for equivalent memory effects. How do we generate theta waves while memorizing? Studies prove when curiosity excites us into anticipatory states, theta waves emerge. Conversely, when we lose curiosity about repetitive things, theta waves vanish. Thus, spark interest in learning, like reciting poetry through song or learning English via movies. If interest eludes you initially, the author advises persisting with study. Every subject has engaging aspects. Persistence reveals learning's fun side. Note: some drugs suppress theta waves, hindering learning. The two common ones are scopolamine and diphenhydramine. The former is in many cold medicines. The latter treats allergies and motion sickness.
So before exams, avoid such drugs to enhance LTP effects.
The second method is engaging emotions. Anatomical precise tone, adjacent to the amygdala, adjacent to the hippocampus. Research shows amygdala activation effectively triggers LTP, meaning we remember emotionally charged events more easily. For example, movie scenes that make us laugh, cry, or rage stick with us. We can use emotion-driven learning to boost memory. For example, when memorizing that Napoleon was exiled to St. Helena in 1815, try doing it emotionally. Napoleon, such a heroic figure, was exiled for life to a remote island in 1815 after his defeat at Waterloo. Success and failure vanish in an instant. Once a dominating force, now without even someone to talk to. What a tragic situation that was. By injecting emotion into historical narratives, you activate the amygdala, making this knowledge easier to remember. If you also develop curiosity about Napoleon during this, generating theta waves, memory efficiency improves further.
Among all emotions, the positive emotion of happiness has the most significant impact on LTP.
For instance, studies show Mozart's music boosts IQ test scores by 8 to 9 points, lasting under an hour, but remarkably effective. This is likely because Mozart's cheerful rhythms generate positive emotions. Some who normally struggle to remember suddenly retain vast knowledge before exams, likely pre-test anxiety activating their amygdala for explosive memory boosts. Of course, this supercharge doesn't work for everyone. As mentioned earlier, cramming large amounts can cause memory interference, affecting exam performance. Plus, stress reactions vary. For some, stress weakens LTP, causing memory decline, explaining chronic underperformance. So, how can we alleviate such excessive pressure? Here's a trick. Before exams, write down anxieties. List troubling content and describe your anxious state to relieve pressure. The third LTP enhancing method is the lion memory technique. Imagine, when would memory help a lion on the savannah? During hunting. Then, lions must draw on past experience to judge easy prey and stealthy approaches. Different prey requires specific hunting techniques, all testing memory. So, which characteristics of lion hunting can help our memory? First is hunger. They hunt when their stomachs are empty. Research shows when hungry, human stomachs secrete ghrelin to stimulate appetite. This ghrelin enters the hippocampus, triggering LTP to enhance memory. Of course, extreme hunger isn't ideal, just moderate crisis awareness, like before meals. Second is movement. Hunting lions pace constantly. Movement generates theta waves, enhancing LTP. So walking while memorizing works better than sitting. Even vehicle movement helps, as long as the brain senses motion. Lastly, cooler environments. Cold signals crisis to lions, since winter hunting is hard, prompting sharper memory activation. Reports suggest the ideal study temperature is around 22 degrees Celsius. 72 degrees Fahrenheit. Beyond review and LTP enhancement, the third memory boosting method is quality sleep. Have you ever noticed this? After all-nighters, next day memory plummets, crammed knowledge often vanishes during exams. Conversely, sleeping after learning deepens understanding the next day. This happens because during sleep, the brain actively reviews and organizes daytime information. The hippocampus reviews information for necessity during sleep. Without sleep, chaotic information gets discarded wholesale. Brainwave studies show sleep effortlessly produces abundant theta waves for memory organization, plus sparks insights. Reviewing problems before sleep significantly boosts next morning's solution flashes. Thus, reviewing material before sleep is a vital study technique. Hearing this, some might ask, what if I'm too anxious to sleep? Actually, don't worry. Sleep's key function isn't about being asleep, but stopping information input to give the brain time to organize. Even closing your eyes to relax in a quiet room or taking a half-hour nap can achieve the same effect. For sleep timing, adjust your schedule based on exam times. A full human sleep cycle lasts about 90 minutes. Only waking near the end of a cycle ensures full energy and a clear mind. So adjust sleep cycles properly. Don't interrupt midway, or you'll end up groggy, hurting exam performance. Based on these methods, the author summarizes a daily study plan for efficient time use. 1. Pre-meal hunger suit study, create cooler environments and memorize while walking. 2. Before breakfast isn't ideal for memorization. Do light calculations or review instead. 3 mornings offer peak alertness, best for logic-heavy subjects. Post-lunch fullness isn't for studying, do relaxing activities instead. 5. Study right before napping to leverage sleep's memory-restoring effect. 6. After school, work, study first, then eat dinner, relax afterward. 7. Pre-sleep is golden memory time, perfect for memorization. 8. Maintain regular sleep schedules, no late nights, to boost memory efficiency. The fourth method is leveraging experiential and procedural memory. Though all memories store as neural circuits in the cortex, they have distinct types. Try recalling your past memories. What comes to mind? Maybe that time you tripped while walking, or what you ate last night. Everyone recalls many things. But notice, these share a common trait. They're first-hand experiences called experiential memory. Beyond this, we have other memories like pi, English words, or the Pythagorean theorem. These are knowledge memory, Knowledge memory can't be easily recalled without the right trigger. For example, you only search memory for the Pythagorean theorem when asked to describe it or needing to use it. Otherwise, it stays buried. Knowledge memory isn't easily recalled. Yet, most exam content falls into this category. That's why we often blank during exams. To change this, the key is transforming knowledge memory into experiential memory through association. For example, during an exam, you can't recall an answer, but then remember seeing it on a specific page of your textbook. When I solved this problem, I was drinking water with snack bags on the desk. If I think by recalling that scene and linking knowledge to environment, you recreate experiential memory and remember. When memorizing, maximize associations. More connections mean easier recall. Like memorizing ambulance as I can't die, while imagining it stopping, doctors lifting patients, making memory vivid strengthens retention. Beyond wordplay, teaching others is great experiential memory training. As mentioned earlier, brains value output as much as input. Teaching is output. Beyond experiential memory, there's also procedural memory, like learning to bike. No matter how much you're told, you must practice to master it. This memory forms subconsciously, becoming extremely durable and hard to forget. Even after years off a bike, you can still ride immediately. Meaning when memorizing, brains unconsciously learn comprehension methods beyond facts. And comprehension methods for many things interconnect. So mastering one thing builds foundational skills for others, enabling broad application. Like badminton players learning ping pong easily, or English speakers picking up French quickly. This is transfer learning. Straight A students often achieve this through cross-subject skill transfer. Top students often have accurate, intuitive flashes guiding their problem solving. This intuition is actually the product of procedural memory. Only through accumulated practice can accurate intuition emerge. Someone who never studies won't experience this. Similarly, many complain school math or physics are useless in daily life. But we're really learning procedural memory through these subjects. Math and physics train logical thinking, skills used in household budgeting, script-killing games, mahjong, and other recreations. That concludes part 2. Let's briefly summarize. To boost memory efficiency, first, use proper review to trick the hippocampus. Maintain curiosity during memorization. Engage emotions and line memory to enhance LTP. Additionally, ensure quality sleep and leverage experiential or procedural memory for efficient learning. So beyond memory enhancement, what else optimizes learning in exams? Next, part 3. The most crucial element is mastering learning's 3 pillars: courage, motivation, and realistic goals. What does this mean? Scientists once experimented by installing a button in a room. Dogs pressing it received food. Initially, dogs didn't know this rule, until accidentally pressing it rewarded them. After repeated tries, they gradually linked button and food. Then scientists added a TV to the room. Now dogs only got food by pressing the button when circles appeared on screen. Ultimately, through countless attempts, dogs connected circles, buttons, and food. This experiment shows learning requires 3 elements: courage to endure failure. After multiple failures, dogs noticed patterns. Human learning is also trial and error. Failure isn't scary, but analyze causes, try solutions, and maintain optimistic persistence. Second is motivation. Hunger drove dogs to find food solutions. Humans are similar. Starting is hardest, and without motivation, learning capacity plummets. For example, studying hard in high school to get into a top university, that's motivation. Or rewarding yourself with 30 minutes of favorite variety shows after finishing a section, that's more concrete motivation. Third is setting realistic goals. Dogs first learned button food connection, then linked them to circle patterns. Similarly, elementary students shouldn't force themselves onto high school materials. That's unrealistic. Step-by-step learning works best, and achievement brings joy, boosting memory efficiency. The book also shares efficiency tips and exam strategies. Studies prove room colors affect learning. Red especially reduces courage to tackle hard problems, so minimize red in study spaces. Green calms minds for study, and background music can help complete silence often hinders focus. For exams, first consider pre-test meals. Carbs like rice, bread, or potatoes work best. They convert quickly to glucose for brain energy, while fats and proteins digest slowly, diverting blood to gut. This reduces cerebral blood flow, hurting exam performance. Second, manage exam time strategically. Mentally split exam duration into two halves. Attention peaks at start or end, but dips mid-session. This division maintains focus. That covers the book's main content. By understanding brain memory rules and optimizing time and energy, we achieve better results in exams, study, and work, living fulfilling lives. All right, that concludes our journey through exam brain science. Reading notes are below the audio. Until next time.